Cloudflare saved 100 terabytes of memory by boxing an Enum variant. We are talking about the infrastructure that powers the modern internet. Cloudflare operates 1.111, the public DNS resolver that billions of devices use daily. When you query a domain name, you expect an answer in milliseconds. But behind that speed lies a massive caching system. Cloudflare processes billions of queries every single day. To handle this load, they keep a huge amount of data in memory. The more domains they cache, the faster the response times for everyone. But memory is expensive and finite. If you are running a service at this scale, every byte counts. This is not just about saving money on hardware, it is about efficiency at a global level. The team realized that their DNS cache was consuming far more memory than it needed to. They dug into the code to find the bottleneck. The problem was not the data itself, but how the data was structured in memory. It was a subtle engineering decision that had a huge cumulative effect. This is a deep dive into how they found the leak and plugged it. The team started by profiling the production environment. They looked at the memory usage of the DNS cache service. The goal was to find the most expensive parts of the data structure. They focused on the enum that represented a DNS cache entry. In Rust, an enum must be large enough to hold its largest variant. This is the default behavior. Even if only a few variants are large, the whole enum takes up that much space. The team analyzed the distribution of cache entries. They found that most entries were small. Only a small fraction were large. This meant the default enum size was wasting memory for the majority of cases. They calculated the total waste based on the number of queries. The numbers were staggering. They were wasting terabytes of memory on unused space. This was the key insight. The structure was correct, but the size was wrong. They needed a way to shrink the common case. The solution involved changing how the enum was stored. It was a classic engineering trade-off between size and speed. The fix was to box the large variant. Boxing means moving the data to the heap. The enum then only stores a pointer. This pointer is much smaller than the large variant. The default enum size drops significantly. For the common case, the memory usage is now minimal. The team implemented this change in the DNS cache code. They had to ensure that the pointer indirection did not hurt performance too much. They measured the cache hit rates and latency. The results were promising. The memory savings were immediate and massive. They saved 100 terabytes of memory in total. This is a huge amount of data. It is enough to store a lot of cache entries. The optimization was worth the engineering effort. It shows the power of low-level tuning. Small changes can have big impacts at scale. The blog post details the exact code changes. It is a great example of practical optimization. It is not just about algorithms. It is about data layout. The total impact was 100 terabytes of memory saved. This is a concrete number from the Cloudflare blog. It represents the cumulative savings across all their servers. This is not a theoretical benefit. It is real hardware that is no longer needed. The reduction in memory usage lowers the cost of running the service. It also reduces the power consumption. Less memory means less heat and less energy. This is good for the environment and the bottom line. The optimization also improved global performance. With more memory available, they can cache more domains. This leads to faster response times for users. The cache hit rate increased. Fewer queries go to the upstream servers. This reduces the load on the entire DNS ecosystem. It is a win for everyone. The team shared these results openly. They explained the trade-offs clearly. It is a valuable lesson for other engineers. Scale changes everything. What works for a small app may not work for a giant. This is why we need to think about memory layout. The post sparked a lively discussion on Reddit. Developers praised the low-level insight. Many pointed out how underrated Rust is for this kind of work. One commenter noted that boxing enum variants is a common pattern. They mentioned that there is even a Clippy lint for it. This lint helps catch this issue early. Another developer compared it to the JVM ecosystem. They joked about the high quality of the JVM Jet compiler, but they admitted that this kind of memory tuning is rare in Java. It is interesting to see the different perspectives. Some developers are used to garbage collection. They do not think about memory layout as much. This post reminded them of the importance of efficiency. It also highlighted the value of sharing internal details. Cloudflare could have kept this secret, but they chose to share it with the community. This builds trust and helps other engineers learn. It is a great example of open source culture. Even for a private company, sharing knowledge is valuable. The comments were full of technical depth. It was a fun read for any systems programmer. The main lesson here is about data structure choice. The way you store data affects performance. Cloudflare measured before they optimized. They did not guess. They used real data to find the problem. This is the scientific method applied to engineering. It is important to measure first, otherwise you might optimize the wrong thing. Scale amplifies small changes. A few bytes saved per entry becomes terabytes at scale. This is why we need to pay attention to the details. It is not just about writing code that works. It is about writing code that is efficient. This applies to all developers. Even if you are not at Cloudflare scale, you can learn from this. Think about your data structures. Are you using the right types? Are you wasting memory? It is a good habit to develop. It makes your software better. It makes you a better engineer. This post is a great case study. It is practical and actionable. It shows how to apply theory to practice. It is worth reading for anyone who cares about performance. So what can you take away from this? First, check your enum sizes. If you are using Rust, look at your large variants. Are they boxing correctly? Second, profile your hot paths. Do not optimize blindly. Use real data to guide you. Third, share your learnings. Cloudflare did this right. They shared the blog post and the code. This helps the whole community. It raises the bar for everyone. It shows that optimization is not just for big companies. It is for everyone. You can apply these principles to your own projects. Start small. Find your biggest memory consumer. Optimize it. See what happens. It might save you terabytes, or it might save you hours of debugging. Either way, it is worth it. Keep learning, keep optimizing, keep sharing. That is how we build better software. Thank you for watching this deep dive. I hope you found it useful. Let me know what you think in the comments. Do you use boxing in your code? Have you seen similar savings? I would love to hear your stories. Keep tinkering and keep building. See you in the next one. Thanks for watching. Check the link in the description for the full Cloudflare blog post. Let me know your thoughts in the comments. Don't forget to like and subscribe for more deep dives into the tools that power our infrastructure. Keep coding and keep optimizing.